Welcome to this lesson on the science of building a minimal viable product, or MVP. Today we're going to explore why starting with a basic version of your idea is not just good advice, but a scientifically sound strategy for product development. First, let's define what we mean by a minimal viable product. A minimal viable product is the simplest version of your product that still solves the core problem for your users. It's not about building something incomplete, it's about building something essential. The MVP contains only the features necessary to test your main hypothesis about what users need. Everything else is stripped away. The goal is to learn as quickly as possible, not to launch a perfect product. This is a fundamental shift in mindset. Let me show you mathematically why perfectionism is so costly in product development. The cost of building a product can be expressed as time, multiplied by resources, multiplied by risk. Each of these factors compounds. Let's compare two approaches with actual numbers. Imagine you want to build a task management app. The full product approach takes 12 months and costs $120,000 with unknown market fit. The MVP approach takes 2 months and costs $20,000 with fast validation. If your hypothesis is wrong, the full product approach weighs 6 times more resources than the MVP approach. But the real waste is even higher. Those 10 extra months could have been spent iterating on a validated idea or pivoting to something that actually works. Now let's talk about the probability that your initial idea is correct. This is where things get interesting. Research from thousands of startups shows that most initial product ideas fail to meet market needs as originally conceived. The probability that your initial idea is correct without customer feedback is approximately 10 to 20%. That means 80 to 90% chance you're wrong about something important. This raises an important question. Why do we think we'll be in the lucky 10 to 20%? This is a cognitive bias called optimism bias. Let's calculate the expected value of both approaches using probability theory. Expected value of building full product first equals probability of success times potential revenue, plus probability of failure times cost. Let's say success means $500,000 in revenue. That gives us $100,000 minus $96,000 equals $4,000 expected value. Not very good. Now for the MVP approach. Same success probability but lower cost if wrong. That gives us $100,000 minus $16,000 equals $84,000 expected value. That's 21 times better. Now let's discuss why early customer feedback is so powerful. This is where the magic happens. Customer feedback doesn't just reduce uncertainty linearly, it reduces it exponentially, because each piece of feedback eliminates entire branches of wrong assumptions. This diagram shows the journey from pure assumptions to validated learning. Each customer interaction moves you along this spectrum exponentially. We can model confidence growth as 1 minus e to the negative lambda n, where n is the number of customer interactions, and lambda is the learning rate. After talking to just 20 customers with the right questions, you learn more than 6 months of internal debate and assumption making. Building an MVP is exactly like conducting a scientific experiment. Let me explain this analogy in detail. On the left, we have the scientific method. On the right, we have the MVP method. Notice the structural similarity. Both are about testing hypotheses with real-world data. Scientists don't build the most elaborate experiment possible before testing their hypothesis. They start with the simplest test that can validate or invalidate their idea. So why would product development be any different? It shouldn't be. Both are about discovering truth through empirical evidence. Now let's talk about iteration speed and why it compounds over time. Total learning equals the number of iterations times the quality of feedback per iteration. With the MVP approach, you might complete 6 full iterations in 12 months. Build, test, learn, rebuild. With the full product approach, you complete 1 iteration in 12 months. You only learn once. The learning ratio is 6 to 1. You learn 6 times more with the MVP approach in the same time period. But here's the key insight. Learning compounds. Each iteration doesn't just add knowledge, it multiplies it because you build on previous insights. Compound learning can be modeled as Q times 1 plus R to the power of N, where R is the improvement rate per iteration. Let's examine the hidden costs of building features nobody wants. These costs go far beyond just money. First is opportunity cost. Every hour spent building the wrong feature is an hour not spent building the right one. Second is technical debt. Unused features still need to be maintained, tested, and updated. They slow down everything. Third is user confusion. Feature bloat makes products harder to use and understand. More features often means worse user experience. Fourth is team morale. Nothing demotivates a team faster than seeing months of work go unused because nobody validated the idea first. Here's a breakdown of the hidden costs. The direct cost might be $100,000, but opportunity cost could be $200,000. Technical debt adds $50,000 per year, and team morale impact is immeasurable but very real. Let me give you a famous real-world example, Dropbox. This story perfectly illustrates the power of an MVP. Dropbox could have spent years building perfect file synchronization technology across all platforms before launching. Instead, founder Drew Houston created a simple 3-minute demo video showing how the product would work. That video was their MVP. It tested whether people actually wanted this solution before writing complex sync algorithms. The result? Their beta waiting list grew from 5,000 to 75,000 people overnight. That's 15 times growth from a video. This validated massive demand before they invested in building complex infrastructure. The video cost almost nothing compared to building the full product. Now let's discuss the psychological shift required to embrace the MVP approach. This is often the hardest part. Perfectionism tells us, I must build something impressive and complete before showing it to anyone. This feels safe, but it's actually very risky. Experimentation says, I must learn what's actually valuable to users as quickly as possible. This feels risky, but it's actually much safer. Here's the paradox. Perfectionism feels safe, but is actually risky with high failure cost. Experimentation feels risky, but is actually safe with low failure cost. The fundamental shift is from trying to be right on the first try to learning as fast as possible what right even means for your users. This requires serious ego management. You have to be comfortable with uncertainty and with being wrong. That's hard for many people. One of the most powerful benefits of MVPs is discovering unexpected use cases in markets you never considered. Instagram started as Bourbon, a location-based check-in app similar to Foursquare. But early users ignored most features and only used the photo filters. The founders noticed users only cared about sharing photos with filters. Everything else was ignored. So they stripped away everything except photo sharing and filters. That pivot created Instagram. They couldn't have known this without launching an MVP and watching real behavior. This discovery only happened because they launched early with a basic product and carefully observed how people actually used it, not how they thought it would be used. Their false assumption was that people wanted location check-ins. The truth was people wanted beautiful photo sharing. No amount of internal planning would have revealed this. Let's create an equation for resource efficiency between MVP and full product approaches. Resource efficiency equals value created divided by resources spent. Simple, but powerful. MVP approach creates 80% of the value with 20% of the resources. Full approach creates 20% of the value with 100% of the resources. The efficiency ratio is 20-1. MVP approach is 20 times more resource efficient. This is why startups can compete with big companies. This explains why small teams with limited resources can outcompete large organizations with unlimited budgets. It's not about resources, it's about efficiency and learning speed. When building an MVP, you must answer 3 critical questions. These are your validation framework. First, does this solve a real problem that people actually have right now? Not a problem you think they should have, but one they actually feel. Second, will people pay money or time for your solution? This is the ultimate validation. Words are cheap, behavior is truth. Third, can you reach these people efficiently through some channel? The best product in the world is worthless if you can't reach customers. Here's the validation framework visualized. Problem, solution, and distribution. All 3 must be validated for success. Your MVP must test all 3 of these, not just whether your solution works. Many products solve problems but fail on distribution or monetization. Let's quantify how MVPs reduce risk mathematically. This is where the science becomes very clear. Total risk equals the probability you're wrong about the problem times probability you're wrong about the solution times probability you're wrong about the market. If each probability is 50%, then total risk is 1 minus 0.5 times 0.5 times 0.5, which equals 87.5% chance of failure. An MVP with proper validation can reduce each probability to 20% because you're testing assumptions with real customers. New risk is 1 minus 0.8 times 0.8 times 0.8, which equals 48.8%. You've cut risk nearly in half. That's a 38.7 percentage point reduction in failure risk. This is huge when we're talking about months of work and thousands of dollars. An important concept related to MVP is the minimum viable audience. How many users do you need to validate your idea? You don't need thousands of users to validate your core assumptions. In fact, thousands of users can actually slow down learning. Nielsen-Norman Group research shows that just 5 users reveal 85% of usability issues. Diminishing returns kick in fast. Probability of finding an issue equals 1 minus p to the power of n, where p is issue prevalence and n is number of users. For product validation, 10 to 50 early adopters is often enough to learn the critical patterns and make informed decisions. Getting more users before iterating just means more people experiencing a suboptimal version. Quality of feedback beats quantity every time. Let me give you another powerful analogy. Building a product is like building a bridge across a river. You're on one side and your customers are on the other side. There's a river between you. You need to build a bridge. The perfectionist designs a complete, elaborate bridge on paper before laying a single plank. They assume they know the river's depth, current, and width. The experimenter puts down one plank, walks on it, tests the current, learns about the river, then adjusts the next plank based on real conditions. Which approach is more likely to result in a successful crossing? Obviously, the experimenter, because they're learning from reality, not assumptions. There's also a time value to feedback that compounds dramatically. Early feedback is exponentially more valuable than late feedback. Feedback value equals V divided by time squared. The value of feedback decreases quadratically with delay. Feedback received after 2 months is worth 36 times more than feedback after 12 months, assuming equal quality, because you can act on it much sooner. This is because earlier feedback allows you to iterate multiple times, compounding the learning and improvements over the remaining time. An important concept is knowing when to pivot versus when to persevere. MVPs make this decision much clearer. Without an MVP, the pivot decision only comes after huge investment. At that point, you're emotionally and financially committed. Sunk cost fallacy takes over. With an MVP, the pivot decision comes after minimal investment. It's much easier to change direction when you've only invested 2 months instead of 12. Pivot probability is a function of investment and evidence. Higher investment decreases willingness to pivot even with strong negative evidence. Low investment plus negative evidence equals rational pivot. This is the optimal situation for learning and adaptation. Let me summarize the scientific case for building minimal viable products instead of complete products. MVPs reduce total failure risk by approximately 40% through systematic early validation of assumptions. They increase learning speed by 6 times or more through rapid iteration cycles instead of single long development. They improve resource efficiency by 20 times on average by focusing only on essential features that create value. They enable discovery of unexpected markets and use cases that no amount of planning could have predicted. They shift team psychology from perfectionism to experimentation, which is more aligned with how innovation actually works. The mathematics, the evidence from thousands of products, and basic principles of scientific experimentation all overwhelmingly support the MVP approach. Here's my final thought. Building products is not about perfection, it's about progress. Perfect is the enemy of good, and good is the enemy of done. But done and tested is the friend of learning. Every day you delay getting feedback is a day you could be building in the wrong direction. That's real risk that people underestimate. The goal is not to build something impressive that you're proud of internally. The goal is to build something valuable that customers actually need and will pay for. Ship early, ship often, learn constantly, and iterate rapidly. This is the scientifically validated path to product success.